key aspect and component of the ROMI project is that it should be open source. So there is no proprietary software, there's no ownership over the designs. In fact, it's created to be hacked, customized and adapted to any farm.
One of the aspects of the ROMI project is the open hardware, and we started from scratch, like buying a motor controller, programming the motor controller, and which is maybe different than many of the projects you might see, more industrial projects, who might rely more on, say, high-end standard components from the industry. But I think there's a real advantage in trying to build everything up, is that first you understand everything, you can explain everything, you can fix anything, you can document anything for DIY farmers that they if they want to replace one motor with another. And understanding that all allows you to quickly experiment stuff without having to depend on someone else who's working with, say, a closed source component. And it allows you to be quite reactive. And of course, in the end, allows you to be fairly cost effective.
No. One of the things we set out to do with this project was to make it accessible. And the idea is that at the end of the project, everything will be open source. So from the frame to the software, the designs, the CAD, everything will be open source. So if you're a maker, if you're somebody who is an engineer and wants to build one of these robots yourself, you'll be able to download everything, including the software, to be able to make it run. And because we wanted it to be accessible, we started out with one thought, that was everything that we put into this rover should also be accessible.
So we are trying to bring that philosophy that is embedded within Fab Labs / maker movement / the open hardware movement of how you design for distributed manufacturing, which means that you take design decisions on the way that you build things, which are meant for others to replicate it in new laboratories, using new machines, and you do that on top of a network such as the Fab Lab network, which is robust yet heterogeneous. No?
Seems like someone tinkered with it. The idea when we designed this is to constrain ourselves to do it in a way that anyone else can build it easily. So we try to keep the type and the complexity of the tools we use as small and simple as we can. So we use 3D printers that today are really accessible. We use CNC machines. That's maybe the most complex machine we use, but it was needed because we need to build something that can stand the weather in a harsh environment in a farm. So we use aluminum and plastic. And the rest of the components are mostly commercial components. So the process of designing it is a come and go between the computer and the farm and the Fab Lab. We tried here with the cable on the office to hang the first versions of the cable bot. Then we come back to redesign the pieces, and then we adjust the sizes of the pulleys and the springs, and then we do another model. And so this ability to reiterate so fast is also provided by the simplicity of the tools we use. Using a really simple 3D printer to build a robot allows you to do in 1 month several versions and iterations of the same robot.
In the end, our goal is sustainability, is not technology. And what is the best way for whatever we build to have an impact on say, farmers in Europe or wider. And if what we do is good, then we would like them to have access to these tools. And there's some sort of a confidence that then there will be some financing flowing back to us.
When we open source this knowledge and these tools, it allows for an abundance of researchers, of practitioners to come together to find the solutions. We don't have to depend on a small development team. So the library of tools that are developed are really a public library for others to use and to adapt.
At the end, I think the most important part that we don't even realize, because we just do it because we are on the inertia of doing it, is that we are setting rocks for the future. At the end, we are not making right now the best robot, the best tool. What we are doing is setting ground to build on the future the best robot and the best thing built by people, not by us, because we are not farmers. We are not going to design the best robot, and we are not a big company with resources as crazy to make the ultra high-tech thing. But we are able to do something to share with people, and a lot of heads think better than a couple of heads. No? The model that Linux, a lot of people in the Linux community use is we're dumber than them, but we are hundreds of thousands. No? Hundreds of thousands of heads think better than 10 heads. So being able to share that knowledge and to include people in the development of their own tools, I think is the best path on a mid and long-term way of seeing this. No?